In this video, we're going to start the process of dissecting that tiny application that we created. So first of all, let's just go through a quick review of what we actually did. We dragged two controls from the toolbox onto the designer surface, and then we went about setting properties of those controls using the property window in the lower right hand corner of Visual Studio. We changed the name property for both of the controls. For the text block control, we changed its text property. And then for the button control, we changed its content property and changed it to click me. Then we double clicked the button, and that popped open a new view that allowed us to see and edit C# code. And so then we wrote the C# code between two curly braces. And I made a point to make sure that we wrote it in the right spot, because there were a lot of places we could write our code there, but it was important that we put it into the curly braces. Then we ran the application by clicking the Start Debugging button that was on the toolbar of Visual Studio. And this opened up a program that looked a lot like the Windows 7 phone. It was actually an emulator, and we looked at that in the previous lesson. And after a moment or so, our application was loaded into the emulator, and we were able to interact with it. So we clicked on that button, and then that text block, which was formerly not visible, then displayed the words "Hello World." So what I want to do in this video is to ask the question why that happened, and what happened. Why did we do what we did, and what result did it produce in that whole chain of action that we took? So let's start with the code that we wrote. The myTextBlock.txt equals open quote, hello space world, close quote, and then a semicolon at the end of that line. We use a programming language called C#. There are many programming languages. C# is one of the main programming languages that Microsoft supports in Visual Studio. And I'd highly recommend that you learn as much as possible about C# in the coming days and weeks if you're hoping to build an application for the phone. As somebody who's been writing applications for 15 years, I can assure you that C# is a great first programming language to start with. And if this is your first experience in writing code, then there's an important distinction to make in your mind as you get started. There's two parts of the process. The first part is learning the syntax of C#. In other words, the nouns and the verbs and the punctuation, if you will, of the programming language, just like in the English language. The other part of the process is learning about the environment, or rather, the platform on which your code will operate. Now, in our case, Microsoft has created something called the .NET Framework, which is the platform on which your application will execute. There are many, many parts to the .NET Framework, but for right now, there are just two parts that I want to highlight and cement in your mind: the .NET Runtime and the class library. Now, each of these go by different names, and I might even use some of the other names accidentally throughout this series, so just be patient with me as I work through this, and just keep your ears open for something that's said slightly a little bit different, because you're going to see it referred to a lot of different ways, even in Microsoft's own documentation, okay? But the runtime is also referred to as the CLR, which means Common Language Runtime. All you need to really do is just key off the word runtime. The runtime is like a car, and your code is like the driver. The runtime translates your code's instructions into action. The driver doesn't care much about how the gas pedal or the brake pedal is translated into all the machinery under the hood to go or to stop. It just issues those commands and then allows the machinery under the hood to do its job. The same is true with the relationship between your code and the runtime. Your code issues commands and the runtime executes it. For example, you don't have to worry about working directly with the computer's memory, or directly with the computer's network card, or the video card to display things on screen. The runtime manages all of that for you. And additionally, it'll protect the computer your code is running on from your code in case it's malicious. So so there's some security baked into the runtime as well. The .NET Framework runtime was originally created to operate on a desktop computer. However, a few years ago, it was compacted and hosted inside of a web browser and given the name Silverlight. So now you can write applications that run inside of the browser if the Silverlight plugin has been installed. The CLR, the runtime, was given a new name for this situation. It was called or known as the Core CLR, and others just call it the Silverlight Runtime. Again, these things have lots of names. You'll see them all. But Core CLR or the Silverlight Runtime. So now we have a new version of the Silverlight Runtime that will run exclusively on the Windows Phone 7. But the same rules apply. The runtime, or rather the Core CLR, the Silverlight Runtime, whatever you want to call it. It's going to host your code, and it'll be the car that your code is driving. Okay? So the runtime is the first part of the .NET framework. The second part of the .NET framework that we're going to talk about today is called the class library. It's known by other similar names like the framework class library, or FCL, or the base class library, or BCL. But whatever you call it, there's tens of thousands of these little functions that contain code that Microsoft wrote so that you as a developer don't have to write that code. These range from drawing things on screen to like windows and buttons and things like we've seen here previously, to saving data to the hard drive, to exchanging information over the internet, and almost anything that you can possibly imagine. There's probably already been something written in the library that can help you write that code. The library contains entire sections that deal with things like creating interactive website applications, also known as ASP.NET. There's entire sections that are dedicated to working with database data, which is called ADO.NET. And in our case, writing rich internet-enabled applications called Silverlight. So now there's new additions to that library that help you write phone-based Silverlight applications, and so that's what we're going to be doing for this series of videos. Now please understand, for the sake of brevity, I completely oversimplified this topic, but we're going to reveal a little bit more and a little bit more throughout this series. And after you get the C# programming language under your belt, then the majority of your time is going to be spent learning things, new things about the .NET framework, how to interact with one part or another of the framework class library. The beauty is that the things that you learn in this series will easily translate into helping you build web-based applications, Windows-based applications, and even Xbox games. So you may be interested in just learning how to write phone applications, but I'm secretly behind the scenes teaching you how to become a .NET developer. Phone development is a great entry point to the world of software development at large, as I hope you'll come to realize. Okay, so let's focus back on the code that we actually wrote in our example here. The my text block, that's the name that we gave to the control that displayed the message on our phone emulator. Now there are many different kinds of controls that we can use within our phone applications. And it's best to choose the right tool for the job. The button control is the right tool to accept an action command from the user. And the text block control is the right tool to display text on screen to the user. But there are many more, and we're going to look at those in the videos on day 2. Next, we're going to set some properties on each of the controls. A property is simply an attribute. It can be an attribute that affects the control in a visual way, or it could be an attribute that affects how the control behaves. On both of the controls that we used in this example, I changed the name to something that's a little bit more memorable. I could have named the controls anything that I wanted to, but I wanted to make sure that it's a name that we're going to be able to remember and easily recognize as we begin to work with it in our code like we did here. When a control has a name, you can reference it by its name in the code like we did when we referenced myTextBlock.text and so on. But we didn't just write this. Let me just remove something here. We didn't write myTextBlock equals hello world. Why didn't we do this? What was the reason? Because there's more to a text block than just its text. Sure, that might be the primary thing that we do with a text block, but it's not the only thing. There's the color of the font, the type of font, the position of the text, the alignment of the text. There's a lot of other properties, and we could have selected it here in mainpage.xaml and looked at all the properties that were available for that given control. The way that you access a property in the properties windows, you select it like we did in the previous video, and then you can change a property about it. The way to select it within your C# code is to first access its name, like we did here, my text block, and then use a period or a dot to access its properties, like we did when we typed in set the text equal to. And that brings us to the next part, that equal sign. It's actually what's called an operator. It's an assignment operator. I want to assign the value on the right-hand side of the equal sign to the property that we listed on the left-hand side of the equal sign. So in this case, we want to set the text property to a new value. And so what is that new value? We set it to the words hello world, and we surrounded those words with double quotation marks. So what happens if we were to remove those? Let's just delete them. What we'll see is a squiggly line, which is Visual Studio's way of telling us that something's not quite right about what we just did. If we were to hover our mouse cursor over them, it'll give us something that's a little bit generic based on what we just did. It'll say the name hello does not exist in the current context. What? You just have to understand that we need to, in this case, surround this string of individual characters of HELLO space WORLD. That string of characters, or rather a string, a literal string. We literally want those characters to be assigned to the text property of the myTextBlocks control. Finally, we're going to talk about the semicolon. And as you can see, it exists throughout our application. Here at the very top, we see a bunch of semicolons. Here in this line of code, we see a semicolon. Here we see a semicolon. And the semicolon is basically like the period at the end of a C# sentence. It completes a thought in your C# code. And as we saw in the previous video, if you were to remove that semicolon, then you're going to get an error message. C# will, as it begins to compile your code, it will raise an error, and we'll have to correct that error before we can move on. Also notice that there's some indentation in our code. Now that's added for us by Visual Studio. That's not something that you have to do. We could just put everything completely left aligned. Why do you suppose there's indentation here? Well, there's indentation to make it a little bit easier for software developers to understand what's going on in the code, what code belongs with what code. And that hopefully will become a little bit more obvious as we work through additional examples and you find out a little bit more about these containers that we've written our code inside of. But it's helped us to make sense, to make it a little bit more readable. And along those same lines, Visual Studio color codes some things. It would be the equivalent of taking a look at a book and seeing that some words, nouns, are in red, and other words like verbs are in blue, and other words are in green. Those might be like adjectives or adverbs or punctuation or whatever the case might be. And the same thing is true here in Visual Studio. Those parts of speech, to further extend that example, are given different colors within our code. Again, to help us as developers, as we get used to this, to become, to easily pick out the parts of the code that we've written or that we're examining, okay, and understand what's going on here. So again, readability, helping us to comprehend what's going on inside the code. Now, when I wrote this code, I made sure to point out that we needed to write it in the right spot. Specifically, we wanted to write it in between these two curly braces, and that's why I put my mouse cursor here and began to type it. What would happen if I were to move that code and put it right below that curly brace? Now let's go ahead and try to run the application. We're going to get a couple of errors as a result. The reason is because this code doesn't belong in that spot. There is a reason why these code blocks here can execute this code, and there's other code blocks like here can't execute that code but contain other types of code. And so we're going to come to understand more about that as we examine the C# programming language. In a nutshell, these curly braces define a code block. And you can see there's various code blocks throughout our code, and some code blocks contain other code blocks, and they all have special purposes. You can think of them as a series of containers. I'm going to oversimplify this just for a moment, and we'll build on the definition later, but this innermost code block that we wrote our code within, it's called an event handler. It responds to a specific action that was taken place by the user. In this case, the MyButton_click event. So this code block, it has a name. Some code blocks don't have a name, and we'll see those as examples later on in C#. This particular one, whenever it's given a name, that means it can be called from another location. The other thing that I wanted to point out here is that we only have one line of code in our code block, but we could have many different lines of code. In fact, many of our applications will have multiple lines of code in several code blocks that will each respond to certain events that are triggered by an action the user or the application itself takes within the application. We'll get back to that a little bit later. Okay, so just to kind of back up for a moment here, the key idea is that something happens on this main page.xaml. In this case, the user clicks a button that requires additional information that is supplied then in this main page.xaml.cs file. So there's a link between those two files. It contains, the C# file contains information about how the application should behave, specifically behave in relation to the actions that the user performs within the application. And so this is an important distinction. As a convention that to help us keep things nicely organized, they are named very similarly. As you can see, this page is named mainpage.xaml, and this page is named mainpage.xaml.cs. And the CS file, as you might imagine, is therefore C#. Okay, C-S-H-A-R-P. And this type of file is called a code behind file. It's code that is behind or supports. It stands behind that XAML file. All right, so on the right-hand side, if we were to take a look at this little window above the Properties window called the Solution Explorer, it shows a relationship between this mainpage.xaml and this mainpage.xaml.cs. All right, gives a little hierarchy there. But if you were to look in the actual file folder, they live kind of as brothers. It's just a way of representation within Visual Studio that helps us understand the relationship between those two files. Okay, and to get to one file or the other, we just have to click it here in the Solution Explorer. Or we could use these tabs at the very top of that main area. Okay, I don't want to dive into this topic very deeply just yet, but I want to remove the mystery a little bit. Let's look at this mainpage.xaml. And what I want to do is select the button control. When I do that, you'll see in this right-hand pane that there is a selection made on this line that says button content equal click me. And if I scroll over here, you can see at the very end there's this click equals MyButton_click. So this just describes that relationship. How is it that this code knew how to fire when somebody pushed the click me button on the phone's user interface? Well, the reason is because there is an attribute of the button called click, and that attribute is set to MyButton_click, which our runtime, the Silverlight runtime or the core CLR, it knows is wired up to execute this named block of code, and it will execute anything inside of that named block of code whenever the user clicks the click me button. Okay, so I just wanted to remove the mystery. There's a lot more to it than just that. But hopefully now you can see the relationship between those two files and how is it that this file knew something about this file. Okay. As we're beginning to wind down this video, let's focus on the name main page. The word page establishes the fact that our applications are using a page or document metaphor, similar to how we might think about a website with individual HTML documents. In this particular application, it only contains one page, the main page.xaml, but we're going to see some examples soon that'll have multiple pages. And when I first started working with Silverlight and phone applications, but specifically Silverlight, it took me a little bit of time before I really understood that it works a lot like HTML, in so much that it's simply defining the user interface. If we take a look at XAML here, this XAML code it's just an XML-based syntax. It looks a lot like HTML, right? With an open tag and a close tag, and elements that are kind of contained within elements that are contained within elements. Each element having some properties that we can set, and so on, okay? So that's the first part of the analogy that I would draw. If you're already familiar with HTML, that will help you understand that the code within the XAML file is just like HTML in so much that it's a metaphor to allow you to express your design intent through a tag-based syntax. The other way that HTML and Silverlight are kind of similar is in so much in the way that the navigation and the pages are laid out. So we have only one page in our application right now, but we could have multiple pages, and the way that you navigate between them is through a URI, which is a lot like a URL, okay? You can even send information between the pages using a query string, and we're going to demonstrate how to do that on day 2 and day 3. So a lot of similarities. If you can get that in your mind as early as possible, that removes, again, some of the mystery with Silverlight. So a lot of this we're just going to put on hold for now. We're going to learn more about C#, come back to these ideas a little bit later. All right. So the last thing I want to say is that the word main page is just the default name that was created automatically for every new project that we create using that template that we selected when we selected File, New Project, and selected Silverlight phone application. In the next lesson, we're going to look at what happens when we delete this default page, this main page.xaml, and then we create another page. And we're going to have to answer the question, how does the phone know how to display the main page.xaml or the new page that we're going to add to our project? And so we'll cover that and learn a little bit more about what's going on behind the scenes here in the next lesson. So we'll see you there. Thank you.